Hello everyone, thanks for watching Cheap Shot. We're just going to play around a little bit in Fusion 360, see if anyone joins us. I'm unsure if I can be heard. Let me just check it on my other device. Can anyone hear me? Is it playing? Oh, I can't tell if it's going.
Hi, I'm Brian Kramer with Cottage Grove Place. There's something very unique about Cottage Grove Place. We're the only very unique about Cottage Grove Place. We're the only.
Can you hear me?
We're the only. Can you hear me?
Oh yeah, we can hear me. All right, sorry about that. So let's look at some things that we can do. Let's go and let's learn something. This is pretty easy to use. This is called a loft. We'll do a sweep first. Some places might call this like a blended sweep. Well, they'll just call it a sweep. So let's say we want to let's make a worm. Let's make a worm, right? So we want to start off and we want to just make a circle. Now, how do we make this, be a worm, be a zigzaggy shape? I mean, we can extrude it, right? But this is only one direction either way. So what we can do is we can do what's called a blended sweep. So we want to create, we have our profile, what we want to zoom back and forth, and we need to create a path of which it's going to follow. So I can make another sketch, and I can make it right here, and I can just make, a pretty crazy path that my worm's going to follow. That might be a little bit too crazy. Finish that sketch. And now I can come into here into my sweep tool. And Cura makes it real nice and easy. What profile do I want to sweep? I want to sweep that circle profile. And what path do I want to do? I want to do that path. Now, unable because the lateral starts off the profile in the opposite direction of the sweep direction. So basically what it's saying is it's off the profile path, which is easy. I can fix that. Fast fact, I've never actually done this in Fusion 360. So we're learning together. Let's do this. Let's start it here, through it, around, and we'll do that. So let's try it one more time. Sweep, path, and see how it's come all the way around. We get finish, and boom, we got a nice worm shape, And like that was pretty easy. Like I said, I had never done this geometry in Fusion 360 before, but they make it pretty darn easy. So, what can you use this for? Obviously, creating more complex geometric shapes. This would be hard to 3D print, especially these areas up here. You'd need a lot of infill. This would work for like a tea mug or something. If you had that, if you had a tea mug that you want to make a handle for. So, I don't know. What else you guys got? Who's got anything for Fusion 360? Please leave it in the chat. Let me know. I'll be more than happy to show you or walk you through it, or we can figure it out together. So let's try something new. Let's do this. It's going to be called a loft. This is when you go from one shape to another. So it looks like it wants two profiles and then a guide type. So let's see how this goes. Let's say we want to take and we'll do what they did in the picture. We'll go from a circle, and then above that we'll go to a square. So we need a constraint, an offset data plane. Let's sketch on this one now, and let's make our square. So we want to make a shape that goes from a circle to a square. So create loft profiles. What's the first profile? We want to do that profile. Oh, it's going to want to, oh no, it didn't want anything. And boom, it just did it. Now I think these are what's going to happen is it's called vertices. So this obviously has 4 vertices. We're going down to a circle that has no vertices. So what it had to do is it had to create 4 vertices for us to follow. So we should be able to grab these and kind of drag them around. See, like that? And kind of drag them around and put those vertices exactly where we want them. You know, if we kind of want to make a twisting motion, we can do that too. Now that's kind of an insane shape for vertices. Let me show you where it might be a little bit better. It might be this would be for like an axle beam, right? So let's say down here you had an I-beam, right? And we're just sketching this very rough. And you wanted to take this I-beam and transition it into a T-beam. So I want to sketch on this plane. If you don't know what a T-beam is, this is a T-beam. You can tell it is because of the way it looks. Right? So let's say I want to go from this I-beam to this T-beam. Let's do that again. Let's do our loft, select the bottom profile and the top, and we can see that it had to make these extra vertices for us to go from that T to an I. So this is where it's beneficial that you can take and move these vertices to just kind of help create exactly the shape that you're looking for. And this is the easiest way to do it. I've never done this before. I've been doing this in Cura for some homework that I got for class. Way easier. Look at that. And that makes it exactly perfect. Now let's say I didn't want those down there. I can just right click on this again. I can edit the feature. I can drag these vertices back to wherever I want. I can have them come from the top if I want. Oops, I broke it. Oh, it's mad. I don't care. That was pretty straightforward and pretty cool. So we've already here in what's it been? It's been a couple minutes and we've already made these 3 complex shapes. So once again, anyone watching, thank you for watching. Please let me know if there's anything in Fusion or Cura that you would like to learn. I am here for you. This is viewer's choice. What would you like to learn in Fusion 360? Let's say we wanted to put a threaded hole in the top of this. Well, we can sketch it. We can get, you know, some diameter of the hole that we want. And then we can extrude it down. That's totally fine. You have a couple options, all right? You can come down any size that you want. I can change it over here. Some other options you have over here is the direction one-sided or two-sided. Two-sided means I can set, hey, I want it down 100 millimeters here. I want it down 40 millimeters in this way. This is great if you're making something inside of a shape. Another thing that you can do is you can do symmetric. So if I'm going 100 one way, I'm going 100 the other way. Another thing that you can do is you can do extend distance. So right now we're in distance. We want to come negative 100 millimeters, excuse me. But we can do all the way through a profile. And the reason we would want to do that is because let's say later on we went and we edited the length of that weird shape. That would keep the hole going all the way down to the bottom of that weird shape. Or we can do 2 objects. We can say, I want you to come down as far as that bottom base. And you can cut it. So then what we can do is we can come in here to create. We can make a thread, and we can just click that inside, and we can adjust this hole, make any types of thread we want. One thing is a lot of times you don't model threads in like engineering, and that's because there's no need to model threads. But if we're printing something, clearly we need. So if I just kept this, it would just maybe, you probably can't see it. It would just, you know, literally like stick some threads on there, like that's what they look like. You know, like an image of some threads. But if we're 3D printing, we want the threads to actually be modeled. So we can come in here, edit this feature, and we can actually click modeled. And then the threads will actually be in there, which is a nice, great tool for us to use. So what else we got? We can do a revolve feature. I just covered that in a fast fusion video. So let's say I want to make a funnel, right? I can revolve this around a plane. Now there's nothing to really revolve it around. I would need to create a an axis for it to revolve off of. And you know, I could do it around that. I'm trying to, yeah, like an offset one. I don't really want to do any of those. So one thing that I can easily do is I come back here and I can edit the sketch. I'm pretty sure if I just give it a line, that'll work too. I'm pretty sure I can say revolve around that axis. Yep, and it'll work. And boom, there's my funnel. Easy peasy, lemon squeezy. So, once again, if you have any fusion questions, please let me know. I would be more than happy to help you with those fusion questions. Let's try some other things. An offset plane, so like I said, everything that you sketch on needs to be done on either a flat surface or a plane. So you may be asking yourself, cheap shot, how do I make that plane? How do I make a plane where I want it? Well, it's easy. You can construct an offset plane, and you can offset it from another plane. You can offset it. What am I, Sean Connery? You can offset it from, well, it's going to get mad. You can offset it from any type of surface. You can offset it from literally anything you want. We also have a plane at an angle, so if I wanted to do something, you know, there, I could, and I can change that angle just as easy. So let's make a plane offset off this top. Let's make it 45 degrees. Whoops. We'll just do that. We'll say 45 degrees. There's our angle. And then we can sketch on this, just like we could any other sketch. And let's just blast a hole through this funnel. Bow! Look at that. Ooh, no, what's better yet? Let's go both directions. Let's come down here, symmetric. Boom. Oh, did it not work? Oh, it's because I missed everything else. No, I shouldn't have. Cut everything else. I want to cut everything. Gosh darn it. I don't know. Oh, look at that. Thin extrude made like a laser beam. That's kind of cool. I joined late. You might have to cover this already, but can you show how to do threads? I would love to once again show how to do threads. So let's make a cap for my oil can, right? So right away we're gonna have our little threaded portion. We're just gonna say 150, and it comes up, you know, 100 millimeters. On top of that, I've got my little threaded portion. We'll say 300. That comes up, whatever, 25. Ugh, that looks ugly. I don't like that at all. We'll say 50. So I want to put some threads right down here, right? It's super simple, dude. You're gonna, you know, I know you asked it because you want to know, but you're gonna feel dumb when I tell you. All right, create thread, and then here I can just click on any round surface, and I can make my threads. I can take and I can adjust the thickness of my thread body to match what it needs to be. And then over here I have tons of profiles already imported in, which makes it super easy. Sometimes you can't find the profile you need, but it works pretty well. A big difference is, you know, I can unclick this full length and I can make it so it only starts at one point, you know, if it's only partially threaded, but most of the time you're going to full length it. And one thing you need to do is you need to hit modeled. Now you can leave it unmodeled, that's fine, but like I said before, it only pops on like a picture of the threads on the model. It doesn't actually model the threads. So if you're going to 3D print this, it'd be useless because it doesn't actually have any threads. So you want to make sure it says modeled. But then you can change up here and really do anything that you want. You could model them separately, but that's too hard. Hit remember if you want to make like a thread and a cap. That way when you do the next size or the other side, it's going to remember what you wanted already. And then boom, I can hit OK. And there's my threads. Now, let's say I want some kind of grippy on the top of this, right? You know, you see all the time, it's kind of, mine's kind of got like a handheld all the way around. So I'm going to take, and I think I'm just going to kind of give it one of these numbers where I'm going to extrude this down. But then what I want to do is I want to repeat that. So let's take this, let's pattern that in a circular pattern. Object axis, we want to be in the center of the circle. And how many times do we want to go? Can we do 10? Yeah, look at that. And then boom, now we got something to kind of grab onto while we thread that in. So super easy how fast we made that, Travis. That was fast as heck, right? Pretty straightforward. Did that answer your question, or do you want to go over something else? I love Fusion. You know, school and work make me use other things. I would use Fusion for the rest of my life. Thanks. Yeah, that was great. Is the same process to make a female portion of the threads? Exactly. So if you remember, I hit, I clicked on remember. So let's say I wanted to make something for this to thread into. I can just come in here. I can make this huge circle. It doesn't matter because I can fix it later. I can extrude it up. I can put a hole. I think I'm just going to put just a little tiny hole in there. I don't know if I really have to, but I'm gonna. And then I should be able to come here, hit thread, hit that, and it should remember what I did last time because I hit remember. So that'll be the female variant of these threads. Now, one thing is 3D printing with threads, if this is what you're intending on doing, is very hard because they're not perfect. So you may want to keep the pitch and stuff the same, but you might want to take it and just drag that out, just make it a little bit bigger, So it's not going to let me because I wanted to remember what I did before. But you might want to make that hole just a little oversized, or change the class. I can't remember if 4G is tighter or looser. 5 looks like we're pretty big, but the corresponding one would be there if you already remembered. So with that print, it probably wouldn't print. One thing that you could do though is you could help it by giving it a chamfer around the lip. And that would just kind of help give it something to help you engage in it if you wanted to 3D print these parts and thread them. So one thing that we can do is, it probably won't let me because I made these all technically on one model. Oh no, they can. You can come over here and you can boop, 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 boop. The claw. Oh, I didn't line that up at all, did I? Let's try that one more time. Let's move that up. Oh, nope, that's ugly. I don't know what I did with that. I'm just messing it up. You can move things. It doesn't really work that well because, like I said, I'm making these all on one part. But normally if you had, this part was your cap, this part was your female end, then you can move it around. You can kind of test fit it, see if it works. It's pretty straightforward. What else you got, dude? The world is your oyster, and I'm your dirty little hoe. I am your dirty little hoe. Let's see here. What do we got? Inspect the center of mass. This is like some Kerbal Space Program. Yeah, it's perfect. Thanks. Yeah, I know, because I'm perfect. No, I'm kidding. That's pretty cool. Center of mass. I didn't know Fusion did that. That works well. I wonder if we can take in a curvature map analysis. Yep, that's curvy. It's curvy, all right. Let's try that on this. Oh, hey, that's pretty cool. When would I use that? I got no idea. So what else can we put in here? Let's do a draft. Drafts are kind of difficult. So let's say pull direction faces. So I think I want to take and pull this direction with this face. Yep, okay. So drafts are really cool for making something bigger or smaller, and you'll use it a lot if you're forging something. And goddamn, like I had, my most recent class had a thing on drafts, and it was so gosh darn difficult. So let's take this draft, our draft direction, our draft face. I can make that a little bit, and I got it. Oh, this just makes me so mad how easy this is to do in Fusion versus what I have to do for my freaking class. This just, oh my goodness, that's so easy. Phil, I'm going to send you this video, all right? And I'm going to make you watch it, and I'm going to show you how easy this stuff is in Fusion 360. Oh my goodness, it's ridiculous. What else can we do in here? Make a coil. Coils are boring. Let's learn how to make a mirror, all right? What can I do for a mirror? Let's say I got this beam right here, right? And I want it to come over the other side. Well, I got two options. I can take it, I can make this I-beam over on the other side, but then I also got to remember I did these drafts. I don't really remember how to do those drafts. Do you know how I did those drafts? I don't remember how to do my drafts. Well, I can come over here, I can mirror it, and I can select the object I want to mirror. I want to mirror this whole thing. Pretty sure I got the whole thing. Good enough. Mirror plane, I can select the plane, or I can select the face. Never mind, I guess it's a plane. That's right, that's the plane I did it. And then, oh, mirror, compute failed. Oh, it's probably because of the drafts. All right, let's delete the drafts. It doesn't matter. I didn't really like the drafts anyway. Let's try it again. Mirror plane. Okay, there we go. It didn't like the drafts. But boom, I just mirrored that. Easy peasy lemon squeezy. Guess what? I can do it again. Oh, no, wait, I can't. Because remember what we just did last time? I tried to do it on a face. It wouldn't work. I had to do it on a plane. But that's okay, because we know how to make planes. So now I can do it. Mirror. Select my plane. We just made one. Or maybe man. Hit OK. Oh, boom. Look at that. That's insane. Guess what? We can do it again. Let's do it one more time. Let's make a plane off here. Hit OK. Select everything. Create mirror. Select our plane. Oh, wow. Look at that. That's a great part. That's a great part. We got a really fine collection of shit here. Of just random stuff we can make. If you're still watching, let me know what I can show you in Fusion. We're just kind of bullshitting around. If you like one of these shapes, let me know. I can remake the shape for you. That is perfectly possible. Let's try and make a McDonald's cup, right? So what do we got? We need a cup, right? And then, you know what? I don't want to do that because we have to have, well, I do want to do that. That'll be the base of our cup, right? And, you know, the bottom of our cup is going to come up, you know, just a little bit. Just got to hold that liquid. But then remember, down here at the bottom, we have we've got a little ring that'll help us support our cup, because we are good fathers. We support our cups. If our cup wants to start an OnlyFans, we'll support it. Hit OK. All right. So now we gotta make like the actual wall of our cup. Whoops. So let's come over here. And I don't know, that seems thick enough. Let's extrude this up. So, what do we got though? You know, the walls aren't just straight. We can make a taper angle. Oh, it disappeared. Where'd it go? That was too big of a taper angle. All right, let's try this again. One. Oh, see, it made it a little bit bigger. I want it bigger though. I want it like 3 degrees. Oh yeah. That kind of sucked. I kind of wanted it to come all the way out. So let's do something else. Let's take and let's make a axis through there. And then let's take and make a plane. I don't know how I can make a plane in the center of that. What I do know how to do though, is I know how to offset this and eyeball it. Is that close enough? It's not. That looks good to me. And then I know how to sketch on this plane. Let's say, you know, let's say we come up. If you're just tuning in, we're making a cup. I can come into the thing, it doesn't matter. And now I can, what am I looking for? Not pattern, what am I looking for? I'm looking for Revolve. That can be my profile. That can be my axis. Ah, boom. I don't want to cut, I want to join. Boom, that's my cup. That's a horrible cup. That looked worse than what we did before. I need to make a lid. Let's, you know, every cup needs a lid. My lid's got to come down a little bit, you know, to securely fasten onto my cup. Otherwise, my drink is just going to spill everywhere. My cup needs a hole, but we're not just going to do any fancy hole, well, any simple hole. Let's give it some like, let's give it a circle. But then let's also give it some of these eclipses. No, I don't like that. Let's give it a slot. So let's give it a slot. I can hit OK. I can extrude this bad boy down. Hit OK. But then that's not a very good looking cup. I can circular pattern that extrusion along. Can I click it? Can I click it? That axis, and I can do that 4 times. Boom! I can put my drink in there, and then I can make my drinking straw. Nope, nope. There we go. Then I can make my drinking straw. Boom! There's my cup. Eat your heart out, McDonald's. That's great. That's absolutely beautiful. All right. Does anyone have any questions over what they would like to learn in Fusion 360? I'll be more than happy to help you figure that out. I've made a lot of garbage. I made a lot of garbage right now. It's been 31 minutes, and this is the garbage we have created in the world. The world was a better place before we started, and now it's the worst place. But we have a Fusion 360 cup to drink out of, to enjoy the end of days. But is that life? Who knows? There's 3 people watching. Someone needs to take and make a comment saying something they want to learn in Fusion 360. Or I'm going to be mad. I won't be mad. I'll just be bored. But it's okay. I've been bored before. That probably won't be the last time I'll be bored. That's okay. Let's play with some of these tools. Let's say accessibility, minimum radius. Tools. Inspect. It says zebra analysis. That is ugly as sin. I'm sure there's a use for it. What that is, I don't know. What could you? Let's make a web. How does this work? Select a curve. And it's probably just selected that part already. Let's say this. Web. Select a curve. I can only select that curve. Oh. That was weird. I gotta play around with that a little bit more. A rib uses the open sketch curve to create a thin feature. The rib is created planar, parallel to the sketch plane. I don't really care about that either. A sphere. You know, for all those round prints you wanted to make, but were too afraid to ask, you can make a sphere. I'm actually kind of digging the way like all these weird items are looking. You know? It's kind of floating my boat. I wonder if there's a way that I can make environment dome. I don't know what that means. So you got shaded, is what most of you are used to. I hate it. Shaded with hidden edges, even worse. Shaded with visible edges. I'm kind of digging it. It's kind of got a Borderlands kind of vibe to it a little bit. All right. Wireframe. This is what I like to, especially when I start getting crazy. I'm sorry, no, I like wireframe without hidden edges. the visible edges. This is what I like to work with. This is my meat and potatoes. The only thing that freaking sucks is when I do something like this, and I take a screenshot and I try and make a gosh darn thumbnail, it doesn't show up. You can't see it. It looks dumb. You know? I don't know. I need a, if any of you can do, you know, graphic design, please let me know. So once again, if there's anything in Fusion I can help you with, please chat. Let's see what else we got here. Mesh display, environment, dark sky. Ooh, spooky, scary. This is for my dark themed friends out there. Gray room. Oh, very depressing. Photo booth. I think that's the default. Tranquility blue. Oh, look at that, man. It is, you know, 1964 called. They want their engineering drawing documents back. Infinity pool. Just give me the biggest headache. Let's go back to the photo booth. What else we got? What can we insert? Oh, this is what I can show you. I should have showed Travis. If you're still here, let me know because I got something better to show you. This is so great. Let's say you need to make a bolt, right? You got a bolt. You're pulling it out of your car. It broke. Oh no! What am I gonna do, cheap shot? I can't go to the hardware store, but I got a 3D printer. Oh please! I wish someone had live streamed how to do this, and then I'd be able to know how to do it. Well, here the fuck I am. You're welcome. We are going to insert a McMaster-Carr component. Anything that you could, hey Travis, what's up? Anything you could, this would have been great. I don't know what you wanted to use your bolt for, but this is a possibility too, is you can load in a model from McMaster-Carr, So let's say you're missing a nut. You can come in here, you can find, that nut that you missed, a hex nut, a medium strength hex nut, and I don't know if any of these will work. I'm just kind of eyeballing it. But I can click one of these. I come over here to product detail, and then I can actually import either a drawing or a step file, and I can actually bring this part in. All nice and modeled. Maybe it's not going to work because I have it's just small. Boom! And look, it's there, dude. It's there. It's easy peasy, lemon freaking squeezy. This is really cool because I don't know about you, but you're like the cool uncle I never had. Oh, fast fact, my sister is pregnant and her due date is my wedding day. So that'll be kind of fun to, and I'm already going to be an uncle because my fiance has a niece. So what if I the same night, I might be like an uncle twice over and then a husband. It'll be pretty cool. I bet I drink more than your uncle though. But yeah, you can import. So one of the things is all of our printers use what? They use those gosh darn 2020 extrusions, right? You can make those. You don't have to buy them. You can make them. And depending on what you want, it would probably work out great for you. I don't actually know. So, if you're actually searching for something, don't actually do it in Fusion 360 because then you can never find it. It just sucks. Use it online. Look, let's say, a single extrusion, 20 millimeters per inch, slot rails. You can come over here and you can get the part number and then search that. Much easier. Some of these don't have CAD files, so be aware. It's not going to let me download it. See what I mean? There's no back button. Specify a length. Okay, got it. Let's say 1 foot. I don't know if that works. Let's try this again. Let's try 20 millimeter, 5 millimeter. Cut the length per inch. 2 slot rails. Let's try this one. Damn, why is it not? It works. Trust me, it works. It totally works. Why is it not working? I don't. Oh, I gotta click it. Oh, all right. I told you it worked. You thought I was lying. You guys sort of had faith in me, but no, it works. And then look, I can 3D print. I can 3D print a rail piece, dude. You want to like? I know. I also didn't realize how big these other parts were. You can like 3D print a little rail piece to attach to your rail piece. Hey, dog, I heard you like rail pieces. Make your gosh darn own. Which is cool because sometimes these rail pieces get expensive. So if you just kind of want to play around with something, dude, just print that bad boy. And then, you know, it's great. I use it all the time, especially at work when, like, you know, we kind of need something or just want to see something fits. Like, it sucks to order from McMasterCard or order from Granger, and then you got to wait for it to come in just to find out it doesn't fit. But you could just pull it in from McMasterCard in Fusion 360 and print it. You know, suck on that, Creo. You can't do that in Creo. I mean, I'm sure you could do it on Autodesk. I mean, that's all Fusion is, but it's pretty great. Inspect. Let's say you pulled in a model of a particular item that appeals to my fan base. I'm not going to say which item that may or may not be. But you know, you want to get some measurements for that. This is particularly good if you're joining on the Discord. All the times we get people saying, hey, the Hellfire model is broken. Hey, the Anderson model is broken. Hey, the Polymer 80 model is broken because I printed it and this bolt doesn't fit. This pin doesn't fit. Blah, blah, blah. You know what? The model's not broken. It's probably your machine that's broken. So you need to come in here, you need to load up the model, you need to inspect, and you need to figure out the size that's supposed to be and the size that your printer printed. So here you can hit lines, you can see how long lines are, radius of curves. If I want to figure out, you know, the distance from, you know, what's the difference from this point, I can hold shift to this point and it'll tell me. That's an important thing to do. If you want to verify shape, or if you took and you did a shape and then you totally forgot, if you totally forgot, like, what size did I make that? Well, you can just come in here and do it. Pretty cool. Construct, you saw me flip around with some planes. You can do a bunch of stuff along those, including making axes. You know, that works too. If you wanted to make an item, you know, for example, let's make a hush stick. I gotta capture those positions I put in, that's fine. You know, let's say you wanted to take in, print a hush stick, you know, you'd want it to come out kind of like this, right? Then maybe out, you know. Come down and there and out. Now I did that little hack before where I had drawn a line. And then we revolved our hush stick. Around that line. You know, but let's say you wanted to make it a little bit cleaner. You can come in here and you can construct axis through a cylinder, and you can put an axis through there, you know. And what that'll do is that'll just make it a little bit cleaner. How do you personally account for shrinkage when printing PLA? Is there a rule of thumb, or just go by trial and error to get the dimensions you need? So, I mean, what are you shrinking? Are you referring to like the holes that I'm talking about? Because you got to remember 3D printers don't like holes. They don't like round things. PLA, I mean, it's not necessarily going to shrink on you. I mean, there's videos on it. I think they account for, I think it's like 2%. But I've never really had an issue with shrinkage. So like, what personally are you encountering where you're encountering like this shrinkage? I'm pretty sure you can just search like PLA shrinkage percentage. Yeah, 2 to 2.5%. I've never really had an issue with shrinkage. Like I got an Arduino and I 3D printed an Arduino holder, and everyone was like, "Oh, like, you know, like your holes aren't going to match up." But I was able to get it fine. So I mean, it's really up to you. You know, of all the time I've been printing, I haven't really accounted for any shrinkage, or I've not run into an issue where a part has shrunk enough to concern me. So, um, but let's say you did have a part and you wanted to account for shrinkage. So I'm not going to do this because I'm not going to save this part because it's a lot of parts. But I can bring in, like, let's say here's an X-Wing kit I printed the other day. When you get those, you know, when you get this, you can import the part, but you can click on it and over here make sure uniform scaling is on, or not. If you don't want to scale it in the X direction, you just want to do the Y, you can turn it off. And I can make that, you know, 2% bigger, 2% bigger, and that could account for it. Mostly trying to get 2 parts to friction fit, which is challenging, but I was also wondering if there's a better way to print a bunch of different prints at slightly different sizes. So this is something that you can do too. So like you can, I mean, you can, so let's say I wanted to make like a ring, right? And I wanted a ring to go over this pencil. There is a guide. Let me pull it up real quick. That has an offset, this one right here, on 3dshimera.com. So gaps, I mostly just leave 0.1 if 0.1 millimeters if I want it to be a tight fit, and then I do 0.25 for a normal fit, and then 0.5 for a loose fit. I don't bother with 0.127. But what you can do is, if you want to test this, Travis, is like, let's say, you know, I have a rod and I want to see what fits, you know, best on it, is you can then model, you know, your ring. You can model your ring to go on it, and then you can just import that same model. So let's do this. Let's say I have got the ring, right? I'm not going to go that big. Let's say 30. One thing that I can do is you have 2 options. So, you know, I want it to be outside 30, inside 20. Hit OK. I can extrude this. Let's say you want to test that, Travis. I want to save this, save as STL. This is going to be my test for Travis. You can come in here to Cura and you can load that test for Travis, right? We want it flat. We can bring this in 10 times. We're just going to do 5 different times. And then I can have this one set for 100, and then I can have this one set for 99, and I can have this one set for 98, and I can have this one set for 97, and I can have this one set for 96. You know, make sure you remember which one's which. But you could do that. No one's saying that, you know, I don't know if you know this, but that's not illegal. You can do that, and you can see which one fits. So let's say you got it to fit. You realize that you like the 98% one. You want it 98% of the original value. So you can come in here to your sketch, and you can do, you know, 15% minus 98, 14.7. Another thing, Travis, is when you're doing kind of like a fit, you know, let's say I wanted to find a fit for something that goes around on the inside, I can sketch on this plane, and I can take and I can right click this down to sketch, and I can offset it. And this is perfect for making wall lines that are exactly how many, you know, if you have, I want 4 wall lines, and it's going to be 0.8 thick, you can do this to make it 0.8 thick or 0.16, so you have 8 wall lines, 4 on the inside, 4 on the outside, and I can make this, you know, negative 0.5, and then I know that it is negative 0.5 from that, and that'll print. And this is awesome for if you're trying to do something that's print in place, you know? That'll print in place. Those two things. Now, is there a opportunity where you'd actually want to do it? Probably not, but we can see that it's going to leave room. So those are a couple different things that you can test for what's the right offset for your machine. You want to make sure that your machine steps per millimeter are good. So if you haven't done a calibration cube in a while, do a calibration cube before you start figuring out what percentage is right for your machine. So, but most of the time you don't really have an issue with it. Friction fit, 0.1 millimeters. And are you using inches when you design? Because I swear to God, if you're using inches when you design, I'm gonna find out where you live. I'm gonna come over there, and then I'm gonna manually switch your fusion to millimeters. One thing is people ask me in the Discord all the time. They get a model, and let's see what happens. Let's come over here. I use metric. Yeah, you fucking bet you use metric. Let's come over here and let's change it to our design is in inches. All the time, people ask me that. They go, cheap shot, my thing is too small. I tried to make a box and it's too small. It's super small. Why? It's because they used inches, not millimeters. So save as STL. We're gonna keep a touch Travis, just why mix up something that's winning. And let's delete this. So all the time, someone imports something, and it's either too big or too tiny. This one, I think it made it too big. Oh, it's all the way up here. Auto scaled. So yeah, auto scaled because it knew it. Cura knew I was dumb, so it auto scaled it. But if it didn't auto scale it, it would have came in itty bitty tiny. All the way down there. There it is. Well, I actually think it's up above. I don't know where it was. But what you're saying is it's basically not the size it needs to be. How do you fix it? 25540. And that goes from inches to millimeters. And it's great. 2540. It's right there on your keyboard. It's so comfortable to do it. Why is this a thing, Cheap Shot? Why 2,540? Well, if I go inches to millimeter, 1 inch is 25.4 millimeters. So I need to go 2,540% bigger. Or maybe it's because it's centimeters. Yeah, whatever. 254. If you load in a print and it's too small, first try 2540. And if that looks too big, then chances are it is in a different metric system. Just go to 1,000, and that'll fix it perfectly. So, Travis, friction fit, just 2.1. It'll probably work. Back to the thing. One thing that we're talking about with circles is 3D printers don't like to print circles. So especially, I mean, they'll do fine with it on the z-axis. So if I wanted to print a circle here, it would print that pretty fine, depending on how accurate my machine is. Yeah, thank you. You're welcome. So depending on how accurate my machine is, it's going to print it no problem. It might ooze a little bit and make it smaller than what I think it is, but it'll still work fine. Printers hate printing in this direction. And the reason why is because we're using flatness to make a circle. So when it prints, let me do this. So when it prints, it's going to take, and it's going to lay down a bead, right? Then it's going to come up and it's going to lay down another bead starting there. And then it's going to start, come over there, and then it's going to come back, and it's going to do that, and it's going to do all that till it gets to the top. And then it's got two options. It can either go bigger, right? If I'm on this line, it can either go bigger and go too big, or it can go smaller and cut it off. When did you go live? I went live 55 minutes and 41 seconds ago. I didn't announce it to anyone because I don't really care. So I downloaded Streamlabs OBS because I wanted to do some like cool graphics because I was like, damn, this looks jank. But number one, they wanted money. So I gave it to them. And I figured I'd refund if I didn't like it. Oh, it was horrible. It didn't work. No one could hear me. I was like backfeeding it, so I canceled it. It's whatever. But back to the point of the story. When you do a circle, it's going to come over and it's going to cut that off. It's going to be too small. You're going to be absolutely angry. You're going to be so mad. You're going to go home. You're going to beat your wife. For text is better order file. I'll get that in a second. So it's going to be absolutely horrible. So what you should do is if you're going to do like a circle in this direction is you should kind of give it a teardrop shape. And you'll notice that on like the Hellfire or like the Anderson lowers, they give it a little teardrop, and that absolutely makes it better for printing in the Z direction. It keeps it from being too small. Is it better to orient it flat around Z-axis or vertical around X or Y-axis? So there is a beautiful cheat, not cheap, I don't know how much it is. There's a poster that is absolutely great for it. Designing for 3D printing, if I can spell, poster. I kind of want to buy this poster, but I really don't want to spend any money. This one right here, this is the one I'd buy. And we can see text looks best when indented into a vertical surface. It reduces overhangs and has better resolution. Yeah, I would agree with that, and that's just because you have more possibility on that, going up than you do down. There's never been an opportunity, unless it's been on the top, where I've wanted to send my text out. So if I wanted to add text to this cube, if I wanted it on this side, I've never had it come out. It just isn't going to work. But putting it on the side, putting it in will completely work. If you really want to make it stand out, you can Sharpie in there or something, which I don't understand. Like that R will print okay, but if I were to bring it out, it wouldn't really work. On the top, you can do it on the top. One thing you need to be aware of is your infill. So infill doesn't really work for support, but it will support that top layer. So if I were to do some text on the top, let's see this. If I want to take this text on the top, you're going to notice that I'm going to have some issues when I print it. And we're just going to go 0.1. And we'll do over here for comparison. Let's create a text. Same thing. O. And let's go down with this one. And then let's save this. What are we going to save it as? You guessed it. Test Travis. Get rid of the old Test Travis. We got a new upgraded Test Travis. It made it huge because it knows we're an idiot. Look at it all the way up there. Get your ass down there. So, oh, we're on the wrong side. So let's slice this, and let's chickadee check it out. So you would think that would print this top and print on top of it, but you're going to notice that when it's printing this top layer, it's because my walls are too thick. So a lot of times it'll take, and like when it's doing this layer right here, it won't print where that O is because it's still expecting stuff to come up. But maybe Cura fixed that. I don't know. But you want to make, so actually that coming up would print perfectly fine, as well as this bottom would print fine too. But you can come down here and you can see what I was talking about with the circle. You see how we've kind of flattened out a little bit with the bottom of our circle, which is why we wanted to come up and flatten it up there. Because if I were to take and flip this the other way around and slice it, number one, it's going to want supports, but we can see where it finally calls it quits. And that would make, if that was a perfect circle, it would make it an issue. But here it's got no problem because it can come all the way around. So, yeah. So to answer your text, I've never had an issue with it on the side as long as I indented it. It looks like Cura's doing pretty good. You could probably do it on the top. I would just stick with indenting it on the side. Really, you can see it. I mean, some people get crazy where they will take, and so remember how I showed you that neat trick earlier where you offset lines? Some people will take, and so like here's my block, they'll make a new component and they'll name it text or something, and then they'll come in here and they'll sketch, and then they'll offset this line, and then they'll offset the other one as well. And then basically what they'll do is they'll do one color of a print and just print the text on the bottom of like their print bed, and then they'll do their component on top of it, so in a different color, so it's like inlaid in there, and that is just extra. I would not do that at all. That is just not worth it. But all right, anyone joining us, we made a bunch of this stuff over here, a bunch of this boring stuff. If no one else has any questions, we'll give a couple more minutes, let me know, because we've been over doing this for an hour and I'm ready to take a nap. So please let me know if you got any more questions about Fusion, Cura, the economy. We'll print too much money. How much is too much? I don't know. But YouTube tells me it's too much. So I believe everything I read on YouTube. And then you gotta join the Discord. And on Patreon. Give me money. I need heart surgery. But I'm drinking McDonald's. Because they got that good Coke. I got the Gold Bond. It's just dry where I live. Oh, yeah. How about moving a hole that's already in an object? Oh, buddy, you have to ask your wife about that, all right? I'm not that big of it. Moving a hole. Did you make the hole? Or is the hole already there? I mean, I can show you both, I guess. Like if it wasn't centered or doesn't line up with something properly. It's easy peasy lemon squeezy. If you made the hole. So for example, the hole's already there. The hole's already there. That's going to be a little bit difficult. It depends on whether or not you have the step file with all the steps that they actually took. So we can come, excuse me. So let's say I make a part, you know, I've got a square. I've got a hole. And I don't like it there. Provided they gave you the file that is already there, the hole's already there. If they give you the right file, you will be able to come in here and select that sketch that they made to make that hole, and you can right-click on it, and you can edit it. You can change its size, you can change where it's at, and it'll change. And then if you, of course, made the hole, you can just do that same step to move it. It's no problem. Now, if they didn't provide you that file, you would want to come in here, inspect the hole. Okay, what's my diameter? I'm 1.2. And then you would probably want to come in here, you know, excuse me. Well, you can do that with Fusion. I love Fusion. You just make a bullshit shape. Come in here, delete your hole essentially, cap it, and then you would make a new hole. So that would suck if you didn't have the right files. You would essentially have to delete it and then make a new one. But if you had the right files, you can move it around. So it's a right click to move it. Yeah, down here, right click, edit sketch, and then I'm just clicking on it and I'm moving it around. You can take and you can inspect it, and then you can change the size. How can I change the size of this? I think I can. Sketch dimension. And then you can change the size of it if you need to. That made it huge. But yeah, just edit the sketch. So I'm just starting out with Fusion. What is one tip that you'd like to give me? When I was in Cub Scouts, when I was in the 5th grade, we were getting our totem chip, which means we could have a pocket knife. And the Scoutmaster or the den chief gave us all a bar of soap. And then she had a thing. It was like, these are all the things you can whittle with your bar of soap. And one was a bear. And I asked my dad, I said, Dad, how do I turn a bar of soap into a bear? And he said, well, it's easy, son. And I'm thinking, oh, yes, he's going to tell me, oh, first you start off with the legs and 2 little feet. No. He just said, take your knife and take away everything that doesn't look like a bear. And I thought, what a douchebag. What a douchebag. But that really, it's really not. It's all about creativity. So, don't be scared to just take something that you have. Like, we made this cup. Is it perfect? No. But, every little tool you learn in Fusion or any type of CAD software is a tool in your toolbox that you can use to make something. So it's really kind of a creative process, is thinking about what it is you want to create and then actually creating it. So it's always really funny when I hear that engineers don't have any creativity, when really they're making these things from nothing using just pulling out in and out shapes. 90% of what we did here was just extrusions. So it's just keep an open mind with it. There's more than one way to use CAD, and that is one thing that I was talking with in one of my courses at school was when you start grading other kids' CAD homework, you start to realize that everyone kind of has their own preferences for how to do it. So don't be afraid to do something in a different way. That's totally fine. So any other questions before we hop off? I wonder what these look like. Some different looks. Ugh. Still think it looks ugly as crap. This is gonna be a good. This will be a good thumbnail for this, I think. We'll make this the thumbnail. Nice. All right. One more time. Going one more time. Does anyone else have any Fusion or Cura or 3D printing questions that they would like answered before we jump off? The stream is your oyster, and I am your sea otter banging against the rock to try and get that delicious, slobbery, snotty goo out of there without any lemon or saltine or a hot sauce or nothing. What's the best / fastest way to replicate things? For example, if you made an American flag with depth, how would you replicate the stars and stripe without doing it all by hand? So, like if I wanted to make a copy of something, if I wanted to redo this cup, for example, is that kind of what you're asking? Enjoy your nap. You enjoy my nap. Frederick. You sound like you're related to royalty, like your second uncle, twice removed, banged his cousin, and now has like land rights in Belgium or something. It's okay. Let's say that's what he was saying until he comments back like he wanted to like completely replicate something. I mean, you can highlight it, right click, and you can move and copy. You can create a copy of something. There we go. But I do believe, I think it's going to recreate it if I take in. I don't recall if it recreates it. If, let's say I come over here and change this feature, I think it's going to recreate it on the other one. Yeah. Is Creo not superior to Fusion? Creo freaking sucks. I hate Creo. No, Aaron. God. Aaron. No. No, Creo is not superior to Fusion. I hate you. I know Aaron, guys. I'm pretty sure. Do I know you? I know you. I don't know if I always know your last name. It's just like, you know, just simple things. Like, you know, earlier before, it tells you like literally what you need to do. Aaron, all right, I made this gosh, oh, it's me. Aaron, I'm telling you, a blended sweep in Creo, right? Here, I did that. What did I do here? I did that here. Look how easy this is, my friend, right? This is how easy a blended sweep is in Creo. I do a circle. I create my offset plane. I can do whatever the hell I want. Let's do a polygon. I'll get to your question here in a second, Travis. I have to show this dude up. You know, look, that would suck. That would suck in Creo. Create a loft, select my planes, and it just does it. It just does it. I can move these all around. I can move them down here. Aaron, I'm telling you, and if I do something wrong, it tells me what I did wrong. Aaron, you can't tell me that this is better, that this is worse than Creo. How easy was that? How easy was that? It was easy peasy lemon squeezy. All right. So no, like a flag where there's multiple stripes within the same object, is there a way to replicate each stripe as you go up? Oh, yes. Oh, yes. I'm glad you asked that. That is a very good question. That's called a pattern. Still be trying to make the offset plane. Yeah, I would. Yeah. All right. I know exactly what you mean, Travis, and I'm going to show you how to do that. Like making let's say like an ammunition hole. Well, we'll just make a flag. It's fine. We can do that. So boom. Let's say I messed up because I've been doing Creo homework, so my commands are all set for Creo. So let's say I got my flag here, right? And I'm going to extrude up. Aaron, do you know what tool I'm going to use to show for Travis? Come up an inch. So you're saying, so down here, I've got my first flag. I should have probably measured this out. But I got my first stripe coming up 1 inch. What I can do is I can click that extrude, and I come over here to create, and I can pattern this, all right? And I can do this in a rectangular pattern. So it's going to ask me what object I want to pattern. I already have that selected. It's going to ask me the direction that I want to go in. I want to go in the forward direction, the up direction. And then it's going to ask me how the total distance I want to go. I don't remember how big we can make this, but that's fine. We have 3 qualities. We want to have like what, 6 for our stars and bars. And I can drag it up. You know, this would be better if I was actually measuring it. But then I can drag it, and I can replicate it like that. And I can either do a total direction. I can say, hey, instead I want it spacing between them. So I want, you know, 2.5 inches between them. And it'll replicate it up like that. Is that what you meant, Travis? I mean, that is called a pattern. It's called a rectangular pattern in this. But that would be a good way to take and make a flag. So let's try and make one all the way. And let's keep it simple. Let's say, what are the dimensions of the US flag? It is 3 by 5. So we are going to go, we're going to go 30 by 50. right? So then let's say, so 3 by 5. So we have 30 divided by 13. Let's extrude this up. I gotta pull that back up. Oh no. There we go. That's exactly what I was looking for. Thanks. So, are you looking to make a flag? Is that what you're trying to do, buddy? So I'm going to come up. Let's say here we got 13, so that means we're going to be 2.03 for each. So we're just doing some napkin math. 2.307, and then this will be, you know, whether or not you want it, which color you want it, right? So I got that. I want to take and I want to pattern it, rectangular pattern. My direction is this way. I think I need 7 for this one. My spacing is going to be 2.037, 2.307. Sorry, spacing. 2.307. That didn't really work. What am I doing wrong? Extend 30. Oh, damn. It takes some playing around with. Or maybe it's because I did 7, I actually need 6. That didn't work. Let's go 7. You're making a fool of me, my friend. Extend spacing. 5. Oh, I need to double it. I need to go 4.62. That's what I need to do. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, thank goodness. All right. And then I want to go on this plane because if I need to get my stars and bars, well, my stars and the stars and bars. So let's take in that. I don't know. Does that look right? And then I want to extrude that down. So we can click on all those. We want to come down 0.5. Boom. Let's make it a little classier. Let's classy up the joint. Let's give it like I don't know. Let's give it kind of like a border. And I come over here and find the midplane. Boom. Come over here and find the midplane. Boom. And then we're set. And you, of course, you know, would want to measure that out to make sure it's fine and dandy. Yankee Doodle dandy, one could say. Right? So now the stars. Oh, make it. You're going to make me make a star, aren't you? I'm not going to make a star. You can make your own gosh darn star. All right? Our flag is going to have polygons. Right? So I come up and I can extend it. 0.5. Ain't making no goddamn star. So one thing is we know that our stars are kind of offset one another from each other. So now would be a good time to maybe come in here and make our second row of polygons. Right? And I don't know. Whoops, not that. I don't know. I'm just eyeballing it, dude. Come up. 0.75. All right. So now we want to take that first extrusion. We want to pattern it. But remember before we just did one direction? Now we want to go 2 directions. So our directions we're going to select are both that direction and that direction. So let's say we want 10 in one direction and 5 in the other, and we can just drag it, you know. Boom. Look at that. And then we can do the same with our other one. Direction this way and that way. That would be like 9 and 4, right? And of course, you know, a little bit of math to figure out exactly where it needs to be. And boom, easy peasy lemon squeezy. We got ourselves a quasi American flag. So that'll look good. That'll look good. I didn't know what you meant at first, but then I remembered because I'm smart. I'm not. I was just too busy fucking smoking and joking with Aaron. All right. Last chance. 30 more seconds for a question, and then we'll keep going. But if we don't get another question in 30 seconds, I gotta do that nap that Frederick wanted me to take. Because Frederick's a boy. Frederick cares about my health. You guys don't seem to care. You seem to use me like a mule or an animal. Joke's on you. I'm into that. It's my kink. Thanks. That was very helpful. Of course, join us on Discord if you have any other questions. There's also a Patreon only Discord channel. If you really want some help, more welcome to join that if you want. Make sure. Yeah. Anyway, go on to Patreon if you enjoyed this. Throw me a buck or two. That'd be cool. I got a couple of new people that just joined. So hey guys, if you just joined, do you have any Fusion 360 or Cura help? If no one else got any help, we're going to log off, but I'll be more than happy to stay as long as everyone's got help. If you appreciate this, please go to Patreon, www.patreon.com/cheapshot. I'll type it real quick. That would be cool, but if not, that's fine too. You just watching is helpful enough. Anyone have any Fusion 360 questions? Let me know. We're going to give it another 30 seconds for someone to answer a question. Otherwise, I'm going to dip out of here. You guys have been a wonderful audience. Everyone except for Aaron. Aaron can go screw himself. No, I'm just kidding. I mean, unless he wants to. He could be into that too. You never know. Look, we made a McDonald's cup. We made a sphere. We made this weird thing. Came over here. I showed Aaron how Creo or Fusion 360 is completely superior to Creo. Once again, anyone have any questions? Played with some things in Cura. If no one has any questions, I'm going to log off then. Thank you everyone for joining. It's been great. I love all the support that you guys give me, and it makes it super fun. I love 3D printing. I love Fusion 360, not Creo. And I love sharing what I know with all of y'all. So thanks for watching Cheap Shot.